Today we're going to talk about bisectors and triangles. Now, a couple things we need to know first of all. When we circumscribe something, that means a circle is around a polygon, or all the polygon's vertices are on the circle. When we inscribe something, that means the circle is inside the polygon, and then intersects with only one point on each side of the polygon. So we have circumscribed and inscribed. Couple other things we should know. Concurrency. Concurrent is when three or more lines intersect at the same point, and the point of concurrency is the intersection point. Specific points of concurrency that we need to be aware of. The first one is the circumcenter. It's the point of concurrency of the perpendicular bisectors of a triangle. So the circumcenter can be in three different points. It can be on the triangle if I have a right triangle. It can be inside the triangle when it's an acute triangle. Or it might be outside the triangle when it's an obtuse triangle. But it's the point of intersection of the perpendicular bisectors of each side of the triangle. The circumcenter of a triangle, circumscribed, so inside a circle is the center of the circle. So the circumcenter here is going to be the center of my circle. The incenter is the point of concurrency of the angle bisectors. And that's going to fall inside the triangle. So when these bisect an angle, their point of concurrency is called the incenter. So we have a circumcenter and the incenter. The circumcenter theorem says that the perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So remember, we talked about, the circumcenter is the perpendicular bisectors, right back here. And the circumcenter theorem then says, so if I have the circumcenter, or the intersection of the perpendicular bisectors, that point is going to be the same distance from the vertices of the triangle. The incenter, which again we look back, the incenter is the angle bisectors. So the bisectors of the angles of a triangle are concurrent, or the incenter is equidistant from the sides of the triangle. So the circumcenter is equidistant from the vertices, and the incenter, which starts at the vertices, is equidistant from the sides of the triangle. So let's look at a couple examples. If GE, right here, is 2x minus 7, and GF is x minus 4, or x plus 4, what is the length of GD? Well, these are the angle bisectors, CG, AG, and BG. So this is the incenter. The incenter is equidistant from the sides. So I know that these are going to be congruent. So x is 11. We plug that back in, and we get GF is 15. Now, how does this help us with GD? Well, we know GD is the same as GF. So that means GD is also going to be 15. If we look at the second one, QN is 5x plus 36, and QM is 2x plus 51. So we have QN and QM. Now again, JQ and KQ are angle bisectors. So this is going to be our incenter. I know we don't have the third line here, but where these intersect, the third one is also going to be true. So I know QN and QM are equal. So by setting them equal and solving for x, we get x is 5. We plug that back in, and we get QM is 61. And again, QM and QO are going to be equal. So QO is also 61. And that's it. Nice and short. If you have any questions, ask in class.